Unit 9 is all about area and volume. Our first two sections will focus on the formulas for our two-dimensional figures, whereas the last three sections of the unit will focus on our three-dimensional figures. In 9.1, we're going to focus on the area, perimeter, and circumference of some of our most basic shapes. It's very important that you know these formulas very well. However, oftentimes they are given on a standardized test, such as the air test. So the one thing that's nice is that it's already given to you, and all you have to do is utilize them and apply them. So at the top of your notes, you see some basic formulas. You have the area formulas on the left for your parallelogram, rectangle, trapezoid, and triangle, and you have your circle formulas for circumference and area. Hopefully, you already know what these shapes look like. If you need a reminder, you can draw a sketch of each shape in your notes if it's helpful. So for a parallelogram, this is a figure with two parallel sides. Often it looks something like this. Oops, let me try to draw a better shape. Or better yet, maybe I can use my shape tool here. So there's a parallelogram. Then we have a rectangle, a trapezoid, and a triangle. Okay. So those are your basic shapes. And then, of course, we have a circle, and if you want to sketch a circle, you can. There's our basic circle. All right, so let's talk about each one of these formulas just really briefly here. For a parallelogram, our formula is base times height. So the base represents one of the sides of the parallelogram. Just like when we did our area formula for triangles, the base doesn't necessarily need to be the bottom. The base could be any side of the parallelogram that you choose. However, the height will always be the perpendicular to that particular chosen base. So if you're going to use the bottom as your base, then the height would be vertical. However, if your base was running up and down vertical, then your height would be horizontal. So once again, the base could be any side. Just choose wisely because whatever base you choose will determine your height as well. For a rectangle, we have length times width, or I believe we used base times height in an earlier section. They mean the same thing. Trapezoid is probably one that you don't use very often and one that most people don't have memorized. It's going to be 1/2 the height times the sum of the bases. So the bases of a trapezoid are the parallel sides. If you need to make note of that in your diagram, please do. So once again, the bases are your parallel sides. So one of these would be your base 1, the other one would be your base 2, and it doesn't matter which one's which. But those are always, again, your parallel sides. Wherever they are. Sometimes they're the top and the bottom, but sometimes they're the left and the right. So make sure you're very careful about choosing your bases because again, like I said, those are the parallel sides, not necessarily going to be your top and bottom. Now your height will actually be the vertical distance or perpendicular distance between the bases. So this is often your height in a parallelogram. All right, triangle, we've seen this formula before, 1/2 base times height. As we had mentioned before, the base does not necessarily always have to be the bottom of the triangle. It could be, but doesn't always. And then the height is the perpendicular distance to your chosen base. For our circle formulas, we have our circumference and area. The circumference is the measurement all the way around the circle, whereas the area is the two-dimensional area that it takes up. So circumference is a one-dimensional measurement, whereas area is a two-dimensional measurement. So keep that in mind. Now in these particular notes, they give you equivalents to pi. However, I would actually stay away from using these mathematical equivalents, and I would just stick to using pi and keeping that as an exact answer. So once again, I would really ignore this notation of our equivalents. This actually came from our old OGT tests, and they provided those as mathematical equivalents. I would not use those because they won't give you an exact answer. Okay, right down below your formulas, we have a little note about perimeter. So perimeter is essentially the sum of all of the side lengths. So for any polygon to find the perimeter, all you have to do is find each side length and add them all up. Okay, so to go ahead and get into these problems, keep in mind that every single one of these will be different. Sometimes your information will be given and it will be a relatively straightforward problem. You can pick the formula, plug the numbers in, and get your answer. However, sometimes the information that you need for the formula isn't necessarily present. So you have to solve for it some way, somehow. So what I would suggest is, as we're going through these notes, I would see if you could find the reference sheet from section 7.2. When we did our tangent lines in our circle unit, I gave you this reference sheet. Looks something like this. It has a reminder about special right triangles, trigonometry, and Pythagorean theorem. We're going to use these three topics as well in this particular unit. So I would highly, highly suggest that you find this reference sheet. Again, this is from section 7.2, and this is going to help you a lot as well, and I'll be referring to this. Okay, so let's get into our first example. We want to find the perimeter and area for the following parallelogram. So let's just start with our area. To begin each one of these problems, you have to identify the appropriate formula. For a parallelogram, our formula is base times height, and that's just listed right above. So if we look at our parallelogram, we need to determine what we want to choose as our base, and remember that that's going to determine the height. Now it looks like we only have two given sides, the 3 and the 1.4. So you could use either of these sides as your base, or you could actually also use the bottom side as your base as well, which is traditionally, I think, what we like or what we prefer to choose, but it's not necessary. In this case, we could use it because in a parallelogram, the opposite sides are congruent. This is one of the properties of a parallelogram. So I know that this side length is 1.4. So let's use that as my base. That's going to then determine what I'm going to use as my height. The height is the perpendicular distance to that base from the other side. So essentially I want to know the distance that runs from the top side to the bottom but perpendicular. That's actually going to be this dashed line on the right, the 2.3. So we have our base 1.4 and we have our height 2.3. Let's go ahead and plug that into the formula. 1.4 times 2.3. Okay. Using a calculator, we could multiply these and we would get 3.22. Now, since this is an exact answer in my calculator, I would not round. If you're getting an exact number that isn't too grotesque, don't round. It's always nice, or it's always important to not over round, because you could oversimplify your answer, and if you're doing like a standardized test, which is computer graded, it could mark you wrong just for something as simple as extreme rounding. So here's our answer. Now, I want to point out that this is not our complete answer, because we found an area, and area typically has units. For area, this will always be a measurement in square units. So our unit here would actually be inches squared. And this is our complete area answer. All right, next up, let's find the perimeter. So the perimeter of a parallelogram is essentially the sum of the sides. We have two given sides. We found the third by identifying that they were opposite. And the fourth side is actually the side that is unmarked across from the 3. Once again, since opposite sides are congruent, I know that this fourth side is also 3. Please note, the 2.3 is not a side. It's a height. It's not an actual physical part of the parallelogram. So you do not use it in your calculation of your perimeter. So, adding up our sides, we have a 3 plus 1.4 plus another 3 plus another 1.4. And crunching these numbers, I believe we will get 8.8. Now for perimeter, perimeter is a one-dimensional measurement, so its unit will also be one-dimensional. So the answer will be 8.8 inches, and that's our complete answer. You should always put units, even if they don't ask specifically, you should always put units because it gives us more information. There's a huge difference between 8.8 inches and 8.8 miles. Okay, so let's take a look at example 2. Find the area for the following triangle. So the first thing I'm going to do is identify the appropriate formula for this problem. Area for a triangle will be 1/2 base times height. So I need to identify a base and I need to identify a height for this triangle. It looks like I'm given a height of 10, which is perpendicular to this bottom side. So it's kind of setting me up clearly to use the bottom as my base and this 10 as my height. Now the thing you want to be careful of is that your base is only the length of the side. So this 3 is actually irrelevant information. It's not needed at all. It's just to kind of throw you off. The base of the triangle will just simply be the 12. So be very careful here when choosing your sides to plug in. So plugging in our formula, 1/2 the base, as I had mentioned, just the 12, times the height, which is also given. So 1/2 times 12 times 10, and if you crunch those numbers, you should get 60. Now let's talk units. We once again calculated an area. Area will always be square units. I don't care what the figure is, area will always be square units. So our units were centimeters, so our answer will be centimeters squared. All right, so let's take a look at our third example. Find the area for a trapezoid. Once again, let's figure out the formula. For a trapezoid, our formula is 1/2 height times the sum of the bases. So let's identify where our bases are in this trapezoid. As I had mentioned, the bases are always going to be the parallel sides. If we look at this figure, it appears that our parallel sides are the 5 and the 2. So that actually makes our bases known. So that's pretty easy. But where's the height? Well, the height is the perpendicular distance, the distance between these two, that forms a right angle, or this blank side right here. Unfortunately, the height was not given, so we have to find the height somehow, some way. When you're missing a piece of information in your figure, look for a triangle. I see part of a triangle, but it needs a third side to make a full triangle. If we look at the top of our trapezoid, we see a 45, 45, 90 triangle. And this is actually helpful because our height is actually one of the legs of this triangle. But it appears we don't know any other side. Or do we? Well, we know the entire length of the longer base is 5. Now, some students may try to jump to the conclusion that this top length will be half of it, but that isn't necessarily the case. You cannot assume that a particular segment will cut another segment in half. We have to look for some other clue. So, look to the other base. That's not part of the triangle. The other base is 2. And since the other base is directly across from the larger base, that means that the smaller portion of the longer base is going to also be 2, which tells me that the remaining piece of the longer base must be 5 minus 2. The whole distance, take away the part that we actually know. So this top portion will be a length of 3. So Using this top triangle, we want to find the height. If it's helpful for you, you can actually recopy that triangle with the information you know about it. We know that the vertical leg is 3. We want the horizontal leg, and we know that this angle is a 45 angle. So it's a 45, 45, 90. So I'm going to take a look at my reference sheet from Unit 7. In this reference sheet, we have a 45, 45, 90 triangle, which we see right here. According to this, the leg times square root of 2 equals the hypotenuse is our equation that's attached to it. But there's one more piece of information that we used in our 45, 45, 90 triangles that wasn't necessarily an equation. And that's that the legs will always match. In our picture, or our problem, we have one leg and want to know the other leg. We don't care about the hypotenuse. All we want to know is the other leg. And it turns out that in a 45, 45, 90 triangle, the legs will always match, so that means that our height is going to be 3. So now we have our bases for our trapezoid and our height for our trapezoid, and we're ready to plug in our formula. If you need to, in your notes, you might want to go ahead and make a note to yourself that the legs match in a 45, 45, 90 triangle. So that way you know where we got the height from. Okay, so let's go ahead and plug our formula. 1/2 the height, which we just found to be 3, times the sum of the bases. So 2 plus 5. When you're calculating this, be sure that you add the 2 and the 5 together before you multiply the 3 and the 1/2. Or if you have a scientific calculator that will do your order of operations, be sure to put those set of parentheses in there so it does combine those first. In doing this, you'll actually get 21/2 or 10.5 in your calculation. Once again, let's put a unit on this. Area is always square units, so if our problem is in terms of inches, our area will be in terms of inches squared. Okay, moving on to our 4th area problem. Here we want to find the area of a parallelogram. Our area for our parallelogram is base times height. So I need to pick a base and a height. And again, make sure you're thinking about which one you want to be your base and which one you want to be your height. Our base is actually not going to be horizontal here because none of the sides are actually perfectly horizontal. You may want to pick the 5 as your base, which you totally could do, but then your height is going to be some vertical here. Now be careful here because you don't necessarily know, it's not necessarily true that these 2 vertices will connect perfectly horizontal. So if you want to make a perpendicular here, you'd have to just drop it here, and you're not really quite sure what that entire length is. What I would actually suggest is using the 18 as my base and using this perpendicular here as your height. And that's not necessarily the best. I'm actually going to enlarge this triangle so that I can use it to find my height. So if I enlarge this triangle, what I'm looking at is something that looks like this. We have an 80-degree angle here in the corner. And you know what? Even that's not that great. I'm going to go ahead and just put an arrow towards it. I have an 80-degree angle. And I actually have a hypotenuse of 5. And I'm looking for the long leg. So how could I find the height? So if I look at my reference sheet, and with an 80-degree angle, you can't use your special right triangles because 80 does not fit one of those criterias. Pythagorean theorem is used when you have 2 known sides and you want to find the third, which we only have 1 known side, so that's not going to help us here. So the only thing that we're going to have to use is our trig. So if you recall, with trigonometry, we're going to first identify our sides as our O, our A, and our H. This will tell us which trig ratio we're going to use. So let's go ahead and label those sides. So in our triangle, if this is our right angle and here is our reference angle, our hypotenuse will be our 5 across from the right angle. Our opposite side will be the H, the height, and our A is the unmarked side. If you recall from trig, we identified the two sides that we either had information or wanted information about, so our O and H in this case, and then that would tell me what trig function I was going to use. For O and H, we're going to use SO. Once we've identified that we need to use SO, our reference sheet tells us how to set up the equation. We're going to put our trig function of the angle equals the second letter over the third. So the trig function in SO would be our S, sine. Of the reference angle, in this case 80 degrees, is equal to the second letter over the third. In SO, that would be O over H. Our O is actually our H, and our H, our hypotenuse, is actually 5. So this is our equation. Once you have your equation set up, once again, your reference sheet will tell you how to solve. So there are 3 ways to solve a trig function. If your variable is on top, you'll multiply. If the variable is on the bottom, you'll swap. And if the variable is on the inside of the trig function, you'll use the inverse trig function. In our particular example, our variable is on the top, so we're in case 1. We're going to multiply by the denominator to solve for that variable. So in this case, I'm going to multiply by 5. In doing so, I will get 5 sine of 80 on the left equal to H. With trig, you're not going to get an exact answer. So you have to round. I would round at least to 2 decimal places. If you do this, you'll get 4.92 as your height. Now we have our height, we have our base 18, we're ready to plug in our area formula. And the area is base 18 times our height, 4.92. Calculating our height, I've got 88.56. And as always, your area should be a square unit. So for this particular problem, we have inches squared. Problem 5. Find the area for the rectangle. So we identify the formula for the area of a rectangle, length times width. Again, you can choose your length and your width. Suppose I choose the long side as my length and the width as my shorter side. It looks like I don't have either side in this particular problem. The only thing I have is the diagonal, but I do have a 30-degree angle formed by this diagonal. And if you recall, since rectangles have right angles, this is a right triangle. So, what type of triangle will I use to solve for my length and width? It turns out, since I have a 30-degree angle, I'm going to use special right triangles. For a 30, 60, 90 triangle, if again you refer to your reference sheet, there are 2 equations that will allow us to solve for our missing sides. Short times 2 equals the hypotenuse. And short times radical 3 equals the long side. For this particular triangle, the short side is actually going to be the W times 2 equals the hypotenuse, which is our 30. And our short for our second equation is once again W times the radical 3 equals the long side, in this case the length. So for these two equations, the only one that we can solve is the one on the left by dividing by 2. And we get W equals 15. So now I know my width. For my second equation, as it sits, you cannot solve because there are 2 variables. However, since we have found W, we can plug in our known W to find our length. So we see that the length is 15 radical 3. We have our length, we have our width, and we're ready to solve our area formula once again. Area equals length times width. Our length is 15 radical 3. And we're going to multiply that by our width, 15. When you multiply radicals, you multiply outside numbers together and inside numbers together. Both of the 15s are outside, so when you multiply them together, you get 225. Radical 3 is the only thing on the inside, so we'll just kind of come along for the ride. And this is actually going to be our exact answer. Our unit will be feet squared, since it's an area. And there's our exact answer. You could also give the decimal equivalent if you multiply this all out, and that would be about 389.71. Again, feet squared. Either answer is acceptable. All right, let's take a look at our last problem for the set of notes, the circumference and area of a circle with a radius of 4 centimeters. So if I want to find my circumference, I turn to my circumference formula found on the front sheet, and that would be 2 pi r. I already know my radius, it's given as 4, so I'm just going to calculate 2 times pi times 4. If I want the exact answer, I'm going to multiply the numbers 2 and 4 and leave the pi. This is my exact circumference. Circumference is a one-dimensional measurement, just like perimeter. So, since my radius was in centimeters, my circumference will also be in centimeters. You could also give the decimal equivalent by multiplying 8 times pi, and you would get 25.13 centimeters. Either answer, exact or decimal, is fine with me, so you choose whatever you like best. All right, let's take a look at the area. Area for a circle is pi r squared. We once again have the radius 4, so plugging this into the formula, we get pi times 4 squared. If we would like to leave our problem as an exact answer, we're going to ignore the pi and just kind of put it out at the end and simplify our number. So in this case, 4 squared would just give me 16. So our exact answer is 16 pi. For an area, our unit should always be squared. So 16 pi centimeters squared is your exact answer. If you prefer a decimal equivalent, you would multiply the 16 and the pi together, and you would get 50.27 centimeters squared. As you can see, each problem in this particular section will be different, depending on the shape, depending on if the information is given or not. You may need to use the Pythagorean theorem, trig, or special right triangles to find any missing information.